How do you fix a legacy product that everyone, from customer to developer, wants to walk away from? In 2017, I inherited an embedded system struggling with unexplained resets and missing data. I worked on that product for 2 years, and during this time, I drastically improved its performance and capabilities. And in this talk, I'm going to speak about it. I hope you will get some useful ideas and inspiration and that you will find it interesting. So first about me, my name is Gili Kamma. I'm really passionate about solving problems and making things work. I have more than 20 years of experience in software. I started as electronic engineer, then I moved to BSP and drivers. I did embedded high-level, C++, thread, over operating systems. I did some backends, C# and Python. And for the last several years, I'm working in the cloud with microservices and Go. And currently today, I'm working in priority as a manager. So I switch sites in the last few years. And my story begins in 2017. I moved to Denmark with my family, and I started to work in Kamstrup. Kamstrup is a very Danish company, and the business of Kamstrup is meters. And when I'm saying meters, I mean water, heat, and electricity. And if to be more specific, smart metering. So smart metering is exactly the opposite of what you see in this image. So instead of a person that needs to come to your house, read the numbers from the meters, and then transmit it to someone else, everything is automatic. I worked on the water domain, and this is my system, the system I worked on, end to end. So on the right, we have the water meter. The water meter is installed in the house, and it measures the water consumption of the house. And every 16 seconds, several minutes, depends on configuration, it transmits it wirelessly. And now imagine you have a big neighborhood with hundreds or thousands of houses. And in every house, we have such a water meter that transmits its measurements. On the other side, we have the ready manager. This is the backend system, the billing. So they are the one that in the end of the month supposed to send you the bill. And in the middle, this is the product I worked on. And it was installed on a very high place next to a big antenna. And it was responsible to collect the meter measurement from the water meters wirelessly on one side, and then it does some logic, and then send them to the cloud by cellular modem or Ethernet. And what is important to understand here, that the business is data. So loss of data means loss of money, and there are fines if we are missing some of the data. So let's speak about the problems. Originally, it built to work with less than 1,000 water meters, and it worked very fine with it. But after several years, there was a demand from the sales department to sell it to bigger projects, bigger neighborhoods. And then they came to a smart engineer. He did some calculation, and he found out that the hardware of the unit can support up to 7,500 meters. So everything is perfect. That's what they sold to the customers. And then in reality, after the site was installed, we found out it's not working as expected. The product was unstable. We had some crashes. We didn't know to explain them. And of course, customers were unsatisfied, right? They didn't get what they paid for. And developers were very unhappy because they got a lot of complaints. And if to be more specific about the problem, we had memory issues. We didn't have enough memory, even though that theoretically we're supposed to have. We had all these unexplained crashes and resets we didn't know to explain. And also occasional data loss during network issues. So sometimes we had problems with the network and everything was fine. We didn't lose the data. And sometimes we had network issues and we lost the data. And of course, none of the errors were seen in the office. So We couldn't reproduce anything, we couldn't solve anything. Very common, right? You're familiar with it. Okay, let's speak about technology stack to understand the environment. So Linux kernel, Yocto distribution, it was old image, no sources. It worked very fine, but I couldn't touch it. 32 megabyte RAM. Okay, it's important because later I'm going to speak about numbers. It was C++ 17, and this is nice, but not really. It was more in a style of C++ 11, a little bit earlier. It means no smart pointers for you. And I don't know if this is the best of all, it was written in Qt. Qt, if you are not familiar with, it's an application framework. It's a wrapper to low-level programming. And the good thing about Qt that it feels like C#. So if you are not an embedded developer, it's very nice to write it. You can write an embedded software without understanding embedded. The bad thing about Qt that it feels like C#, but you don't have a garbage collector. And it really encourages you all the time to allocate objects, but it doesn't encourage you to release the objects later. So it's a problem. If you have enough resource, it's fine. But if you don't have enough resource, it can become a problem. Okay, so let's speak about my goal. So I was new in the country, new in the company, new in the project team. Everything was new. And that was the goal. I was receiving, reduce to zero loss of data, and create a stable product. Okay, so how am I going to do that, right? Very simple. So that was my plan. It was in a time I was very naive about it. I will say, okay, I will analyze, I will go over the code, understand how to put a breakpoint, where are the logs, how to run the software, look at the main modules in the software, understand the main flows. Okay, and after that, the plan was to reproduce the errors on the table, and then when I can reproduce them, of course, I can solve them. Okay, first impression. So I went to the code and started looking at, and I saw a lot of news and deletes, and I was like, it was the first time I saw something like this. I was really shocked about it. But then it clicked me, and I said, okay, I understand it. It explains everything, right? It probably means I have memory leaks. It means when I'm allocating, but I'm forgetting to release the memory. And probably I have memory fragmentation. And this is like 20 seconds about memory fragmentation. So let's assume I have 100 free bytes. And now I'm allocating 40 bytes and 20 bytes and 40 bytes. And now I'm releasing the 40 and the 40. And now I want to allocate 50 bytes. I can't, right? It's pretty frustrating. Even though I have the memory, I can't. Now imagine all your memory looks like this. This is memory fragmentation. So you have the memory, but it's organized in a way you cannot use it. Okay, so it explains why I don't have enough memory. So my allocation fails. So I'm accessing null. Of course, I am not checking before, if you wonder. And I'm getting this uncontrolled reset, QED. Right? Wrong. Wrong? It's not wrong, but it's wrong in this case. So let's go back to my previous slide. So I had some memory leaks, but not so many. And I didn't have memory fragmentation at all. But in this point of time, I was sure this is my problem, and all what I need to do is just clean some of the news, and everything will be fine. Anyway, so I had my theory and assumptions, and I needed to test it. So I developed two tools for that. And the first one was memory profiler. The memory profiler gave me a good understanding of the sizes and the quantities of the allocation. Unfortunately, I couldn't use standard memory profiler as the Linux kernel was old, so I couldn't touch it. And I needed a way to understand what is happening inside the software, as I am not the one who wrote it. And in general, when we are looking, when we have a dynamic allocation and we are using memory profiler and everything is good, I expect to see something like this. So I'm allocating and releasing, allocating, releasing, but I have some upper limit some constant value, I am not crossing it. But when I have memory leaks, it's going to look like this. So I am allocating, releasing, not everything, allocating again, not releasing everything, and so on. So over time, we see that my peak memory is just increasing. In some point, I don't have enough memory, and I am crashing. So let's speak about interesting measurements I did. So the first one was number of allocations per second. Let's assume I have only 2 dynamic allocation per second. Maybe I don't like it, but the system can work with it, right? Not a problem. Let's take the other side. Let's assume I have 2,000 dynamic allocation per second. This is something else. Nothing is going to work. Current and maximum number of allocation. If we don't have memory leaks, we expect the maximum in some point to be stable, constant. But if it keeps changing over time, we know we have memory leaks. Also very interesting to look at the current allocation because it see how it changes over time. Also, current and maximum bytes allocated. Similar, not the same. And here also the same thing. We expect the maximum to be constant in some point. And if it's not, it means we have memory leaks. We are not releasing everything we are allocating. This is another very interesting current and maximum allocation per size value. It means how many allocations of 100 bytes I have, how many allocations of 1,000 bytes I have. Why this is so interesting? 2 reasons. One, if I have a specific memory leak, it's much easier to catch it because I see a specific maximum value of specific size that keep changing. So to catch it, now I know what is the size of the object that I have leaks in it. The second thing is about memory fragmentation. If all my allocation in the system will be 100 bytes, I'm not going to have memory fragmentation at all. When I'm going to have memory fragmentation, it's when I have a lot of allocation and in different sizes. Okay, let's speak about implementation. So it was C++, of course. And what I did, I overloaded the new and the delete operators. It means that I replaced the default implementation with my implementation. And what I did in this new implementation, 2 things. The first one, I updated my profiler with each allocation and release to do this all accounting I showed you before. And I added extra 4 bytes to each allocation. And in these 4 bytes, I wrote the size of the allocation. Why I did it? Not because of the allocation, because when I'm allocating, I know what is the size of the allocation. But when I'm releasing, I have only the pointer. Okay, so I want to know when I'm releasing something, I want to know what I'm releasing now. And let's look at the implementation itself. So this is my new function. So here I'm allocating size plus 4 bytes. I'm writing the size in the beginning, updating my profiler, and returning to the user pointer plus 4 bytes. So he could use it. Delete, exactly the opposite. So I'm getting a pointer. I'm taking 4 step backs, updating my profiler, and release the memory. So how it helped me? For 2 weeks, I just cleaned all these small memory leaks. I was very happy. It's very nice. But after 2 weeks, I understood all of them were minor. I understood this is not my main problem. I really tried hard to find the big memory leaks that explains everything, but I didn't find it. So it took me 2 weeks to understand I am in the wrong direction. And I also didn't find any memory fragmentation. Okay, the second tool I was developing was a load simulator. And the load simulator helped me to reproduce the real-life scenario of thousands of water meters around me. In the office, I had around 300 water meters. And this is a really nice quantity, right? But you can imagine yourself, my unit worked very well with this quantity. And we saw a lot of problems in big sites when we had thousands of water meters. So that was the motivation. And the idea I had was to base my simulator on what I have in reality. So for every real message I received from a real water meter, I was creating up to 100 fake messages from fake water meters. And in this way, I tricked my system to think that it has thousands of water meters around it and not just the real 300. So let's look at the code. So this is the struct of the message. So there is opcode, an ID. This is a water meter ID, a unique ID, and value. This is the measurement. Okay, so we are getting in. And the idea here that this is my real software. So this is the software of the unit. So this is internal simulator, not external tool, but internal. But it's internal in my software. So I am in the receive thread, I'm getting in. This is a new line. Here I'm checking, it was a Linux system, so here I'm checking if I'm working with simulator or not. And it's based if there is a file there or not. So it's very easy to put a file in the unit and remove it from the unit. Okay, while true, we are getting in. Here we are receiving a real message. So we are receiving the message is received true, moving on. And then I'm taking the real message and push it to a queue. Till now, it's even not the simulator. And then I have another thread that's taking it from the queue, the message, and process it, and does everything that it needs to do. Okay, so this is the simulator part. If simulator enabled, true, we are getting in. And now what I am doing, I'm duplicating the original message, modifying the water meter ID to be a unique ID, and take this fake message and put it exactly in the same queue as the original one. And now I'm doing it up to 100 times. Depends on configuration. And in this way, I trick my system to think that it has thousands of water meters instead of this real 300. So look at this. This is the simulator. That's all. 10 lines of code. And it worked. The unit crashed on my table when I simulated 6,000 water meters and put aggressive configuration. Okay, what does it mean, aggressive configuration? So if I have message A that I need to send once an hour, and message B I need to send every 10 minutes, and message C I need to send every 5 minutes, instead of this, message A I'm sending every 5 minutes, message B I'm sending every 4 minutes, and message C every 2 minutes. Okay, I wanted to put a lot of pressure and load on my unit. I wanted to see it, I wanted to break, and I wanted to fight the bottlenecks. So that's the way I did it. Okay, what is special here? No special hardware required. So no need to fight over the signal generator with the hardware guide. A simple implementation, you saw it yourself, 10 lines of code. Easy access to simulator mode without additional building. It's nice because we want it to be easy to use, and then I used it all the time. So you don't need to build a special version to be able to test your software. And the best of all, it consistently crashed the system. Okay, so I've come across many problems during these 2 years development. Some of them were big, some of them were small. I'm going to share four of them with you. Okay, so the first problem I want to speak about, unexplained crashes. And that's what I had. Unexplained crash after crash continuously with gaps of several minutes in big sites. And when I'm saying big site, I'm speaking about the amounts of water meters. So more than 5,000 water meters, and we just crashed every several minutes, we just crashed. And of course, the first time they told me about this problem, I was sure this is something about the hardware, right? We are really good to blame the hardware as embedded developer. So they brought me the unit, and it's pretty expensive, and everything was fine. So in this point, I understood 2 things. One, this is not something about the hardware. It's probably something about software. And the second thing, that this is something about the amounts of water meters. And that was my main motivation to develop the simulator load I just showed you. But now I have, in one end, I have the simulator load. So I know to reproduce the crash. And on the other end, I have this my new implementation. So here in this line, I put a conditional breakpoint. And this condition, and my condition was, if pointer equal null, please stop. And this is very nice because I just ran the simulator and then I was stopping here. And this is like, it's before I am crashing. So it's very, very nice. So you can just look in all the call stacks and the variables and all the thread, everything is open. It's before the damage is done. So it's very, very nice. And it's reproducible. So we can do, I did it again and again and again till I understood what is happening there. And that's what I found out. I found out that two threads tried to create large messages about 5 megabytes each at the same time. The second one always failed. I didn't have enough memory in my system. Okay, now imagine this issue on your system. How would you solve it? So take 20 seconds to think about it. In a minute, I will share with you how I did it. Okay, so the first thing I did was to change it from asynchronic work to synchronous work. So instead of two threads that are running in parallel, I deleted one of the threads, and now only one thread was responsible to prepare and send message A, and then, if it's needs, to prepare and send message B, always in a row. And by doing that, I was reducing the memory I need from 10 megabytes to 5 megabytes. Okay, so I'm not crashing anymore. That's nice. Can I stop here? Of course, no. One, I'm greedy. And second, I wanted to support 7,500 water meter and not just 5,000. So let's continue. So we are here and continue. And then I start to think about it and I ask myself, why doesn't it happen in all sites? I'm supposed to see these collisions everywhere. I have thousands of sites. Why I didn't see it? Why I'm not seeing it? So I dived into the code to understand what is happening there. And that's what I found out, that the message size was proportional to the number of the water meters the unit listened to. So when I was listening to 5,000 water meters, I took all their data and created a big, happy JSON message. And over that, I needed also to encrypt it. And after that, I was compressing it. But in my peak, I needed this 5 megabytes. And when I had only 1,000 water meters, I took all their data. But in my peak, I needed only 1 megabyte. That's all. And I had 2 megabytes in my system. So if I had 2 messages of 1,000 water meters, it worked fine. But if I tried to do that in big sites, it didn't work. Okay, so my solution, after understanding that, so my solution was to split the large messages into smaller ones. So instead of doing everything together, just do it in batches. So instead of, again, taking everything, so I need the 5 mega. Instead of this, I just, every time I took a batches of up to 1,000 water meters, took all their data. In my peak, I need only 1 megabyte. Then I compressed it, and then I'm taking the next batch of the next 1,000 water meters. So now, instead of 5 megabytes, I need only 1 megabyte. That's nice. The next step I succeeded to do is regarding the Qt. Qt, as I told you, it's a high-level framework. So you can imagine yourself that when we are speaking about character, it will be 2 bytes. And in C++, it's 1 byte. So everything there was written in Qt, so I didn't touch it, but I touched only the message, the function that prepared the message and the message itself. And by doing that, I was reducing the memory I need from 1 megabyte to half megabyte. And then I start to ask myself, okay, if I need only half megabyte, I don't need to do a dynamic allocation. I can do just a static array. That's it. I have enough memory, right? And of course, if I'm not doing a dynamic allocation, I cannot fail in dynamic allocation. And what I just showed you now was the bottleneck of my system. And after doing all these improvements, I could more than double the amount of water meter I could work with. Okay, next problem. Not enough information after crash. Okay, so I had standard application logs. It was Linux system, non-volatile logs. It means that it survives a reset. It is very nice. But unfortunately, as the Linux kernel was old, I didn't have a remote access. So in my office, I have logs, but in reality, in the real sites, I didn't have. But we had something else instead. We have event mechanism that was based on the RAM. And every several minutes, it was collecting interesting events from the unit and send them to the backend. So it's partial logs. And when everything worked fine, it worked pretty well. Again, it was implemented only in the RAM. The problem was when I had these crashes and reset, because then I couldn't see anything. Everything just disappeared. When I had these crashes, because I don't have enough memory, of course, I didn't have enough memory now to allocate the event, prepare the message, and send them to the backend. I didn't have anything. I was crashing, that's it. And then after the reset, the event mechanism looked in its queue. It was empty, right, after reset, and I didn't get anything. I just saw the reset, and that's it. And I was very frustrated about that. But then I woke up in the morning one day, and I got an idea how to get this information. And that was the idea. When the unit wakes up, I will send the last 100 lines from the application log to the backend using the event service. So I called tel-n 100 with my log and put it to a string, short log, and then I just send it as event when I just was waking up, reset reason. And that's it. So every time I had a reset, I also got in my backend the last 100 lines from the log. And it was very, very effective because it gave me eyes to understand what was happening there before the reset. And one of the things I choose to do, it's not to put any if there or any conditions, even though there are cases that we don't need these 100 lines, right? We can think about it. But I didn't care. I wanted to be there always. And this is a good example to good enough solution. Okay, it's not perfect. There are edge cases. You can think about it. But for me, it was good enough. 80% results, 20% effort. Okay, next problem. Occasional data loss during network issues. Very popular if you work with network. Don't think there is one that is not familiar with this. Data for transmissions remains in RAM, awaiting more processing. Okay, so what is the problem with that? That in case of unstable communication, it starts to aggregate in the memory, and it takes a lot of space, and in some point, we don't have enough memory, and we are crashing. And the second thing, that sometimes we have reset, like bad weather or some short maintenance event, and then we are just losing everything we have in the RAM. We don't have any control of this situation. And my solution was to disconnect the logic from the network. Instead of doing everything in the same place, we have this three decision if we have a network or we don't have a network, what we should do. So instead of this, I just put it aside. Instead of this, that's what I did instead. So I created two threads, one responsible for the logic. So he's the one that knows when we're supposed to send the data. So he takes the data, create the message, and put it to non-volatile queue. Non-volatile, it means it survives resets. And the second thread, responsible for the sending. So he's all the time goes to the queue, see if there is a message there, and if there is a message there, he takes it, and tries to send it. And if it succeeds, great, you just go back to the same queue, remove the last message you just succeeded to send, and take the next message. And if it fails because there is a timeout or a bad acknowledge, it's okay. It will just wait another minute and then go back to the same queue and take the message again. And the idea here that we always execute exactly the same logic. And we store the results in non-volatile memory, regardless of the current network status. Network status is very tricky because there are two reasons why. One, you can check the network and everything is fine, but now in 2 milliseconds from now, it's in a different status. So it didn't help you that you checked the network before. And the second thing, that maybe around you, you have a really good network, but not around your backend. So you are sending the network, everything is fine, but you are not going to succeed to send this message. Okay, implementation achievement. 1, maximum data loss is now limited. Think about it. If once an hour I'm taking the data, put it to non-volatile memory, and I'm deleting it only when I'm sure that the other side received it, I'm never going to miss more than 1 hour of data. It's super strong. And the second thing, I'm not being sensitive anymore to network errors. If for 23 hours I don't have a network, and then I have 1 hour that I have a network, everything will be sent this through 1 hour. And I can do it a day after day after day. Or let's take another scenario. Let's assume that now for 2 weeks I don't have a network. It sounds silly, but sometimes someone forget to pay for the SIM. And then after 2 weeks, he will pay. Everything will be sent to the backend. You are not going to lose anything. And indeed, after implementing this change, we no longer experience any significant data loss. And this is a good example of always using the same scenario to avoid any edge case. Okay, last problem, and this is more embedded problem. Suddenly, no meters are being detected anymore. So this is my system, and next to me, I had another unit I didn't mention before, the RF receiver. And it was the unit that was connected to the antenna itself. So it received the RF frame and translated to message, and it sent me to the ready concentrator using UART. This is a very popular or common serial port. And we had sight and everything worked fine for weeks, and then suddenly we stopped receiving frames. And what was interesting, that the system doesn't recover on its own. So nothing was changing. We just have the unit with hundreds of meters, everything is working, and suddenly we are not hearing any meters anymore, and we are still connected to the backend. So the backend knows we are alive, but we are not sending any data. And customer, of course, complained because they didn't get their data. And every time it was a different unit, so I couldn't blame the hardware, right? I told you I love to blame the hardware, but I couldn't. We didn't understand why it happened. And the good news were that a controlled reset solved the problem. So when we just reset ourselves, everything was fine again. And that's the reason we understood it's something about us and not about the other unit, because control reset solved it. And that was the first solution. And my team did it before I was joining them. And the idea was to limit the damage. So if we were detecting this 1 hour of silence, okay, we just reset the software. And it solved the problem. After several months, I was working in the project. I started asking myself, why we are waiting 1 hour, right? If it's not recovered itself, why to wait so long? So I found a new sweet spot of 4 minutes. So I kept all the logic. I just changed the number there, the threshold. And my customers became very happy, because now, if before once in a while they saw this 1 hour missing data, now they didn't see it. They have only 4 minutes, and they didn't notice it. I was less happy, because I knew I didn't solve anything, right? It's like a nicer band. That's what I did here. But I needed to move on, so I moved on. And then months later, I was looking in logs of a unit that had this silence issue, and I realized that the RF receiver, the unit next to me, reset itself, not me, the other unit. So what was happening that I was receiving frame 1, frame 2, frame 3, and then the other unit reset itself, and I got some junk. So my UART driver wasn't able to align again on the next frame, even though that the other unit sent me frames all the time. And after I was understanding that, I could choose a real solution. So I initialized the UART when I detected silence instead of a controlled reset. And the reason that controlled reset worked, because that after the controlled reset, we were just waking up and then we were initializing all our drivers. So instead of initializing all the drivers, I initialized only the UART driver, and it worked. And sometimes it takes time to identify the real problem, so we use temporary solution in the meantime. Okay, let's speak about monitoring. When I started working, every several days we got complaints that some of the unit is not working, and then we went to the event service and to the backend, and we tried to figure out what is happening there, and most of the time we didn't understand what is happening there. And most of the time it was like, okay, just reset the unit, and 99% of the time it worked. And after several years, I was exactly in the same position, and I was super frustrated about it because I all the time got complaints. No one likes to get complaints on its work. I didn't change anything yet. And I understood I'm not moving anywhere because I'm exactly in the same spot. I don't understand what is happening. So I decided to change what I'm doing, so maybe the results will be different. So I started to look actively at the event service, and the idea was that maybe if I could look there actively, I could find some patterns and detect some problems, and maybe I could reduce the number of the complaints I'm getting. So that was my motivation. So how I started? I started reading events for specific units, but it was very uncomfortable. Okay, it was a simple UI with, I don't know, 20 lines in the screen, not very comfortable to understand the system. So I was complaining as a good developer, and two nice students that sat next to me suggested to write me a script to retrieve all the events and save them to a local text file. I told them this is a great idea, and they did it. But then I had a really long local text file. It's not very nice to read it. So I understood I need to do some improvements. So I wrote a Python script to analyze the text and export it to a CSV file. And the reason to do it for export it to a CSV file, that I could put it in Excel and use the sort, filter, graph abilities of the Excel when I'm processing the data. Okay, so this is an example. So I was sending data once an hour. So now when I'm putting it in Excel, it looks like this. And in Excel, it's easy to calculate gap. And then maybe to find that I have error. That when we are doing it manually, it's very easy to skip. And what is nice here, that I don't need to do it only for several hours or for one day. I can do it for days and weeks and months. This is super strong, so you can just take your data, go over months, and make sure that your system behaves exactly the way you want it to behave. Another example, memory usage. I was very sensitive to memory. So here, every 10 seconds, every 10 minutes, I was sending the memory usage to the backend. So it looks like this. And now I can graph it. And this is very nice, but this is not effective because this is like a very short time. But now again, think about it. Days and weeks and months. How powerful it is to see your memory usage over time in your unit and to find problems and errors. So I ran the script every morning, analyzing them for 10 minutes daily. And then if I found some problematic unit, I was connected the support guy to connect the customer, and also all the time verified that what I'm doing is right, and I all the time use it to improve my software. And over time, I added more units and more parameters, and then I needed to take a step back, because to look at graphs, it's nice when you have 1 unit, 2 units, 3 units. It's not working when you have tens of units or hundreds of units or thousands of units. I'm not speaking about 4. So that's what I did instead. So I did a summary row for every unit in my system, and I have thousands of units in production. And when we are looking this like this, it's much easier to catch things. Like here, my firmware is not updated. And if I just looking in its log, I'm not sure I was seeing this, right? Because it's very easy to miss. But if you see that all the others are F2 and this is F1, you say, okay, interesting, why this is different? Errors. So if all the others are 0 and I have 1 unit with 87 errors, I know I have a problem there. So it not explain me why I have a problem there, and maybe I will need to go to the specific logs of this unit, but it direct me to this unit to look at. This is also interesting. Last time. So in the end of the day, my unit, the ready concentrator, all the time supposed to send data to the backend. So, and this is the last timestamp that the backend saw my unit. So it's supposed to see it all the time. So if it doesn't see it, we have a problem. So here we see that all the others last seen around 10, and this is around 1. It means that there are 9 hours of missing data. And in this case, I was connecting the support guy, and 99% of the time it was or a power problem or a network problem. Over time, we automated the script to run them at night and receive results by email in the morning, and we did some summaries, so we won't need to go over again thousands of monitoring of results. Okay, let's speak about testing. After several months, I felt I'm ready to release the software, so I came to my team and asked them, okay, how did you release before I was here? Right. You already released this once. And they gave me a really nice test paper, manual test paper, 100 pages. This is a real story. And they told me we were 3 engineers and we worked on this 6 months. And I was just looking at them, and it was Denmark, so I really tried to be polite. So I'd say, okay. And I just thought to myself, okay, I'm only one person, and it's not going to happen, but I need to test myself, right? So let's do what I did instead. The first thing I did was to rewrite a test paper from manual test to automatic test. It means to remove some of the tests and modify the other tests. And because it was before the AI, it took me a week. And also in this time, my team leader then had another team of students. So he gave me this team to help me to write the test, and they are the ones that did the implementation. I was guiding them. And this is 2 decisions we took regarding the implementation. One, to have 2 pipelines, one for long tests and one for short tests. Some of my tests took hours. Some of my tests took minutes. So I didn't want the long test to block the short test, and that's the reason why we did 2 pipelines. And the second decision was about to run them 24/7. And the reason to do it, it's not because I think that the second time we are running exactly the same test with the same software is going to be different from the first time. I'm not there. It's because I wanted to promise that it always be stable and not flaky. So after we got a new test, we just put it to the pipeline. And if it didn't behave nice, it's even one time it was flaky. I didn't count to 3. I stopped in the 1. We just removed it from the pipeline. We gave it back to the student and asked him to prepare his homework again. And in the beginning, it was a little bit hard, but in some point they understood the idea of this stability, that we are not going to skip this, and it became very, very stable. So we always knew that if we see green, this is green, and if we see red, this is red. Another thing I did was regarding system tests. So I had around 10 units that were running with load simulator and aggressive configuration 24/7, and another 10 units that were running regularly with standard configuration 24/7. And the idea here is not about running them, because then we are just testing the power. It's not interesting. What is interesting is the monitoring. And when I'm speaking about monitoring, I'm not speaking only about searching for errors. It's also about verifying the positive behavior. If we're supposed to do something once an hour, let's verify we are doing it for long periods of time. And general about testing, the question isn't if there is a bug, it's who will find it first. That's it. So how did it end? 8 months later, product without any resets, and it supports up to 10,000 water meters instead of 5,000. 2 years later, test automation, half automatic monitoring, and I'm saying half because we still needed this person to go over the reports and connect the support guy if needed. I was able to release every 2 to 3 months. Instead, these 3 engineers 6 months before me. And I was able to add features and improvements we couldn't put before because it was unstable. Take-home messages. Measure everything. Avoid assumptions. Remember my first impression, how wrong I was. Write robust software. We cannot control the inputs and the environment, but we can control our behavior. We shouldn't crash no matter what. It's okay not to do what we are requested to do if we can't, but it's not okay to crash. And examples from my talk: split large messages into smaller, worked with fixed sizes, decouple logic and network operation. Reduce the number of threads. The most challenging bugs in the system arise from multiple threads running simultaneously. If you don't must to put a thread, don't put it there. Monitoring. Be proactive. Don't wait for customer complaints. It's never getting better because someone is complaining about it. And last but not least, work with simulators. Don't wait until the end of the development. Start with it. And especially now with the AI time, no excuses why not to use simulators. Thank you. Questions? I'm not sure. We have time? Yes, we have plenty of time. Any questions or something? Yes.
Yeah. So I have a question regarding the thing that you shown for like meeting management. So what year was that? And I'm sure you must have tried the hardware upgradation as well. So like, at what extent could you solve the problem with the hardware upgradation, and where you had to go back to software to solve the problem of scaling?
Again, I'm not sure I understood your questions.
Okay, so first of all, like, what year was the?
It was 2017 when I started to work on that project. I finished in 2019, but the product already was there 7 years old. So it was created in 2010.
Okay, so you mentioned there was like only 30 megabytes of RAM available.
Yes.
So,
I think in general, I will think about RAM. It really depends in which system you are coming from. There are some systems that 32 megabyte RAM, It's a lot, okay? It's like, it's imaginary. There are some systems you have half megabyte and say thank you that you have this half megabyte. So it really depends. If you're coming from a place that you think about gigas, you just look at this and say, why are you kidding me? Well, this is like a 32 megabyte RAM. But again, it really depends on the unit. There are a lot of different units with different RAM. Depends what you need to do. Depends if it's connected to a power or not.
So did you try to upgrade the RAM to something like 1 GB there, and how it affected the scaling issues?
The scale issues?
Like with the meters, number of meters you can support, right?
Again, I'm not sure I understood the question.
Okay, so I would say like you started with 30 megabytes RAM for the system, right?
Yes.
And with 30 megabytes RAM, it was able to support certain number of meters, right?
Yes.
So you must have tried to upgrade the RAM to something like...
I couldn't upgrade. Again, this is a specific hardware. You cannot touch it. This is like a live product that already was installed in thousands of sites. It's not something you can touch at all. So, and again, the problem wasn't the amounts of memory we had. It was that when it was first developed, they wrote it to support up to 1,000 water meters, and it worked fine with this number. So everything was good. The problem that in some point, they just decided that we can support up to multiply it by almost 8 and say, okay, it's just supposed to work out of the box, and it didn't. It's never tested to this number of meters. So of course it didn't work. So that's the reason for this talk and all the optimizations I needed to do.
Okay, so you did load testing. What was the most popular issue that you find, and were there like patterns on there? Like what were the main issues that you find in the load testing?
In the low what?
Like load testing the system with more number of meters, right?
Again, I'm not sure I understand the question again.
By doing load testing, what was the main error you found, and was there pattern to spot them?
Okay. In the load simulator, you are speaking. Okay. Again, the idea that I had problem that I could only reproduce when I had a lot of 1,000 meters, and that's what I did in the load simulator. And I try to do it as simple as possible. You saw it yourself. Again, I was one engineer, so it's not. Of course, you can develop a really sophisticated simulator. There are a lot of ways to write simulator, but again, I was only one engineer, and I wanted to have results fast. And that's the reason I did it this way. So instead of inventing some other unit that can send it or use a signal generator or doing anything that it's more common in the industry, instead of this, I did something that it's a little bit dirty in one side, but in the other side, it was super effective and very fast to implement. You saw it yourself. It's like 10 lines of code. It's nothing to write. It's just to figure out the idea. So what took me time is to figure out how to do it. The implementation itself, and I think all the examples here of the code I showed you, it's very, very simple. Because again, I was one developer, and I think my expertise is not about writing a lot of code. Yes?
I have a question. So it looks from your own overall message that you brought there are good practices, in fact, in this place, best practices. Like, why do you think most of your advices are related to best practices? So they're very simple. So why do you think it hadn't happened before you?
I think several reasons. One, when they first wrote the software, I think most of them weren't embedded developers. Most of the original team weren't embedded developers. And that's the reason why they choose to use Qt for that. They just write it from a functional perspective. They just want it to work, and they test it again for these 300 around them, and it worked fine, and that's it. And it was also, I think, good enough. Okay, this ready concentrator supported up to 1 million water meters. It's a lot. And the system now, I think probably it's already replaced with the new generator, but for many years it worked. And the second thing I think about good practices, there are some things today that we are looking at them and they are trivial, okay? Writing, I don't know, Python script to analyze logs. Today we are doing it with the AI, but even using a Python to analyze things, this is like a very common practice today, but it wasn't 10 years ago. It was much less popular. I don't know if you remember. Most of us are old enough to remember this. So some of the things that today we are looking and say, oh, this is trivial, it wasn't. And I think in general in software, there are a lot of things that after, it takes a lot of time to solve them. And after we see the solution, we say, oh, that's trivial. So why didn't they solve it before me, right? I don't know how many times people told me that. And I said, okay, so why didn't you just solve it?
Patrice has a lot of constraint here. I can tell he's wanting to ask this. Did you consider using fixed size pools for repeated allocations of the same size?
No, the reason I didn't want to do it, it's because this is a lot of programming. This is a lot of writing code. For example, take my the event monitor, okay? I could write it in a non-volatile way, right? But I choose not to do that because I choose like a faster solution to implement. So of course, maybe if I didn't succeed to do it the way I did it, maybe this is another way I could do that. And maybe this is even a better way. I don't know, I never chose it. I chose one way and it worked for me. And I'm not saying this is the best path, but again, for me it worked. And again, the thing here that I really optimize my time and the amounts of code I wrote. Again, it was a working system. I didn't want to touch. I wanted to touch as little as possible. I didn't want to refactor everything. And again, I don't know if I was refactoring everything, it was better or not. But I choose not to do that. Not to take everything and say, okay, this is garbage and put it away and write it from scratch. Okay, so I preferred when I didn't need to, I prefer not to write a lot of code.
Following up on the development practices question, you are painting a picture of this organization where if it works, that's good enough. I'm wondering, how did you convince management or whoever to give you the time and the people and budget or whatever to make all these, like, I'm going to invest a bunch of time automating our tests. How did you sell that idea?
When I was joining the team, they were very frustrated. Most of the original team left the company. Some of them left to different projects. Most of them just left the company because they were so frustrated. They put me there myself to do that. And again, they were so frustrated and they didn't know what to do. Because again, this is a project that sold to the customer and it didn't work. And because they were so frustrated, they just were happy. And the first time, they give me some feature to put there. And I told them, it's not stable. I cannot touch it, okay? I cannot put an extra feature of something that is not working. And then we took the step back and I told them, okay, I think I can do that. And that's what I was focusing. And again, I think they already were developing the next generation. So all the other team members already work on the next generation. I was the only one that worked on the legacy product. And they just want me to hold this till the new one will be ready. So I think it really depends how much, what they need, what they can lose. So it depends on the pain, okay? So if you are trying to solve something that there is no pain for no one, no one will give you the resource, right? But if it's painful, they will give you the resource, because again, depends much on alternative. So in your case, I don't know if it's pain, it's your pain or also someone else's pain. To say, okay, we are developing very slow because we don't have tests, and I could double the velocity of my of me creating a new feature. So I think maybe it will help to convince them. Anything else? Yeah. Okay. Thank you very much, and have a nice day.